5. 5 times 5 is?
25.
Yeah. Hey folks, welcome out this afternoon. And it's Specialized Segments again, yes, and I'm Ernie Roberts, I'm your host. And you have found Mathline. You are the right place for a great half hour of entertainment. Well, hopefully so. Also, hopefully some learning skills, all right? We're doing Specialized Segments today. And you know what? What that means is you don't have to call in, no call-ins. You can still write us and question us and say, what were you thinking? All that kind of good stuff. But anyway, please do that. Let us hear from you. Facebook also is still good. But what we do want you to do is get some pencil, paper, and maybe even a little grapher calculator close by, or just a calculator close by if you wish. And we're going to do some math today, all right? And we're going to work out and practice a few things and hopefully get you a little more test prep oriented for all those great tests in the course, end of year, ACTs, SATs, all those things. We're about that today, all right? So let's see what our topic is that we're going to focus on during this day's Specialized Segments. We are going to look at writing linear equations. And probably for the most part, we'll be using that slope-intercept form, but we may go off the beaten path a little bit to the standard form or the point slope, all those good things. So just be tuned in. But we're going to write linear equations. Let's see what our first problem has to offer us today. It says, write the equation of the line in slope-intercept form passing through the point, you got it, 3, 4, and the slope, negative 2/3. Now, what's going on here? What's going on here? You're putting this on a grid. It's on a coordinate grid, and we've got this point that's going to be what? 3 to the right and 4 up. I never do this because it's always backwards. It's mirror image on TV. You know how that works. That's why we don't wear slope-intercept on our shirt or anything like that, because it'd be backwards. But what we do know is that we've got to make sure that we put that in the right place, and then we're going to look for a line that is going to be taking basically a negative direction, a slope of negative 2/3. We'll put it on the graphing calculator at the end just to check ourselves to make sure we did correctly. Now, I mentioned a couple of forms, and slope-intercept and point slope are the ones I tend to like to use on the show. And what goes on, we can do point slope and take you to slope-intercept, and that's where I'm going to start on this one. But for those of you who may not be familiar with it, it's also sometimes known as the multi-purpose linear equation, generator, form, whatever. It's a multi-purpose type thing because we can move to standard form very easily. We can also move to slope-intercept form extremely easy. So here's the formula as it is. It's basically take your y's, and notice we don't have y1 minus y2 because, well, there's only one x and one y here, so we're not going to worry about it. We're just going to use the y open, all right? So an open y minus the y, first y, which is our only y we got, and we're going to put the m. M always stands for slope. You got that, right? And underneath that, or next to it, now we're going to put it underneath it, we're going to put it right next to it, is the x, and we're going to do the same thing, x minus the point value of x we've got there, the coordinate we have for x. So there we go. Everybody look at that. That's pretty easy. And guess what? I gave you 3 of the parts. It's easy. It really is easy. So keep the y open, just like I said we would do. And be sure, and this is, yeah, we want to make sure, because sometimes it's easy, as Ernie Roberts will occasionally switch them around. But put the 4 in for y, all right, equals, and we got negative 2/3. And you got x minus what we got there? We got a 3, right? Everybody look good? I hope you're working along at home. By the way, we encourage you to work along at home with us on these problems and see how much you really know and what you remember and what you don't have to worry about. Now, at this point, what's the storyline? You got it. We need to do a little distributive property moment here. So again, remember, this is what we call point slope. Point slope, because basically we're using a point and a slope. That's pretty straightforward, isn't it? So keep your y minus 4 and let's distribute this negative 2/3 right through there. Well, you know what? That's going to give us negative 2/3 x. And it's going to give, oh, watch your sign. It's going to give us a positive something. Well, let's see. The 3's are going to cancel out. Looks like we're going to have plus 2 there. All right? And all we got to do now is get y by itself. Remember, now we're going for slope-intercept form. Now, why do we do y equals by itself? It's so much easier to graph a solution. It's so much easier to see the graph if we've got it that way. Or the other possibility is standard form, we use intercepts. But in this case, we got a fraction. Let's just play it out. Let's take care of business. And that's going to give us, oh, add 4. Yes, how about it? Y will equal now by itself negative 2/3 x. And we're going to add 4 to that 2, which is going to bump that up to a 6. And my bet is 3, 4 is going to work really well in there. All right, put a 3 in there. It does get you back to 4. Now, another way we can check that, let's go ahead and see what it looks like visually on our grapher here. All right, so let's go ahead and hit y equals. In this case, it was a negative. Don't put the subtract. It'll give you a syntax error, and you'll go like, what do I do now? Go back and hit that little negative button at the bottom. That's what you want. Find your x. There it is. There's a little key up there that says x, t, theta, and n. You worry about x. It'll go there automatically unless you've done some crazy moves from pre-calculus in there. And some people do. Just be careful when you go through there that it's in that form. And you've got an x, you got a 6. That's what we said we had. Let's put a graph on it. Well, certainly I said it was going to go downhill, and it did. It goes downhill. And the question is 3, 4 on it? We can trace this real easy. I love the trace button. Hit that and put your 3 there for x and see what happens with y. It goes to 4, so we know we have the correct line and an easy visual check there for our answer. Now, that's what I said with basically when we get back to this problem here, we were talking about using point slope to start with. Another option, and I know some teachers do this, and there's nothing wrong with it. There's nothing wrong. I just really, I don't know what it was. When I started using this, my students in my math classes, they all of a sudden quit making so many mistakes as they would when we started in this point. And I said, let's show what we got. We got x, we got y, we have the negative 2/3. So we put a 4 in there equals a negative 2/3 times 3, and then we would add b. I'm not quite sure what happened. I think maybe some of the things that would happen was when we started talking about parallels and perpendiculars, they started getting, getting a little bit more confused and worrying about the intercepts and but anyway, at this point you're just looking for b, the intercept, okay? And these will cancel out, and it looks like you're going to have 4 equaling negative 2 plus your b. I can't always guarantee they're going to cancel out. I did that nice just to review with, right? And then add that 2 over there. Goodness, we got the same story, don't we? But instead we had put the -2 moving it over there, but it still came out to the formula. And by the way, you come back, keep your slope, which you were given, and plus 6. So whichever way you like, usually the slope-intercept form is where we like to get to in the end. I still think point slope is an easier way to work through it for some reason for students. And honestly, I think it may be all a mental block up there. But I do find this works better. So getting to the right answer with more students more times than not. Okay, so enough of my little what I've seen kind of thing. Let's look at another one here. Let's go through another example here. Let's go through it real quick. Let's use point slope. And this one says, write the equation of the line with slope of 2/3. So here we go. It's always good to write that formula down until you learn it. And once you learn it, probably no need to keep writing it down. But I like it just to start with, keep us going fresh on that. And we know this is our x1, that's our y1. We'll put it in the right place. Yes, we will. All right. So how about it? We got y minus a 1. That was easy. Over here we got a slope, this time of 2/3. So we're not going to have to worry about sign changing, but we may have something to worry about here. Let's not get too excited yet. X minus that, negative 6. Now, caution right here. It's not x minus 6. It's x minus, and you've got to have that little negative 6 on there, because look what's going to happen. We're going to go, yes, adding the opposite right there, and put a parenthesis around it because the 6 is going to be taken in with the 2/3 also. We'll distribute, kick it through real easy. You got y minus 1 equaling 2/3 x. Oh, what's 2/3 of 6? Well, how about it? We can knock 3 into 6 because 2 times 2, we got a 4. This time it looks like we're going to have y equals, I'll go ahead and kick that 1 over, right? 2/3 x plus 5, all right? And a quick check, mental, you can do this, or you can go back to the calculator, either one. But with a mental check, put the negative 6 in for x and put a y in for 1, see if it's true. And my goodness, believe we're going to get, what are we going to get here? We're going to get a negative 4 plus 5, which is going to give us 1. So it does check back through for us, works very nicely. Also, of course, you can use your graphing calculator and play the trace button, and the same story will be true. Remember, that's not a subtract 6, that's a negative 6 when you punch that into your calculator to check with it. And you get a syntax error, you go, what happened? Look and see which button you pressed. All right, so that's where we are on these two. So everybody good on that? Nodding heads out there. Let's move a little further along here. Let's suppose we have this situation. It says write the equation of the line passing through the points 5, 4, and 3, -1. I tell you what would be fun is if I had a graph paper grid or something there, but let's say we don't, all right? But what's this still the same thing? We're trying to write y equals mx plus b, all right? We're trying to get the point slope business. But you know what's missing here? What do we have on the last two problems? We have a slope given to us. We don't have a slope this time. But we've got 2 points to play with. Isn't that exciting? Everybody goes, oh, yeah, right, Keep with me. Now, what we are going to do, though, instead, what are we going to do instead? How about it? Let's go for a slope. That's what we need. So got to remember that little formula, that good old slope formula. It says if you do rise over run, that would be similar to, well, it would be exactly the same as the difference in y. So why not? We'll call this x1, y1, x2, y2. Reminder, those 2's don't mean a hill of beans, except they're the second x and the second y. Those are not squared, so don't get excited, all right? Some of you do. I know. Now, what we're going to go with here is, remember formula? How about it? y1 minus y2 over x1 minus x2. And some of you say, I always thought it was y2 minus y1 over x2 minus 1. That's fine also. As long as you pick and stay going in the same direction, just don't decide, I'll do y1 minus y2 and then decide to change order here. That will change your sign and that will mess you up big time, all right? Slope, the sign is a major importance, so we will make sure we got that correct. So let's play this thing out, see where it is going, all right? Going hopefully in a good place. That's what we would like to see. So here we have it. Put your y's on top. It looks like I said y1 minus that, so why not? We'll go 4 minus a negative a 1 here. And you know what's going to happen there? Yes, my friends, it's going to go 4 plus 1. Don't mess up there. And then we got 5 minus 3. That one's pretty straightforward, isn't it? And it's going to give us 5 halves, 5 over 2. Let's leave it in proper fraction form, all right? We know it's greater than 1, and we know it gives us kind of a steep line. If we were to connect those 2 points on a graph and draw the line, that would be pretty steep, and it's going to be giving us that good old positive feeling, all right? Positive direction, going toward the upper right-hand corner, right? So let's see how we're going to work this thing. Remember I said let's go point sloping. So how about it? Y minus y1 equals the m times x minus x1. Formula down again, one more time, all right? Put that formula right back in there. And I want to draw a little line down here because we're going to play on one side and then we're going to see what happens should we use another point, all right? Now, which point do we want to use? It doesn't matter, right? Because they're on the same line. They're on this line that has a slope 5 over 2. So let's just play off the first one. That's as good as any. And don't you all agree? Nod your heads. Thank you. So we got y minus, what's the number here? It looks like 4. Equals, m times, what is that? X. Oh, we know m, don't we? We just found it, right? Let's put it in there. Let's make life easier, okay? Well, let's rewrite that. Y minus 4 equals, that's why you do math with a pencil, okay? On the show, I sometimes get a little carried away. And by the way, we are going to put that in as minus 5, because that's our x, right? Everybody's good. Now, it's time to, I think we've got a 4 up there already. I don't know why I decided to put a y back in there, because they look a lot alike. So, dear friends, that's a 4. That's a 4. So let's click this thing through. Everybody saying, thank goodness. Yes, we are glad. We're going to keep y minus 4 there. And it's going to give us 5 halves x. And I know it doesn't work very well, does it? But let's make that into a nice mixed number. We're going to say 5 times the 5. It doesn't cancel. Sorry, my friends. I wished it did, but it didn't. But that's okay. We got, what, 20? 25, right? 5 times 5 is 25. Don't say 10. That's plus. We're multiplying. Over 2. So that looks like a minus 12. I'll put a half there, all right, in decimal form. Now, I'm going to slide it right around the bottom here, and we'll just try to remember that I did that. We're going to make y equal to, goodness sakes, what is that going to be? 5 over 2 x, or 5 halves x. And we're going to add 4 to that. So, my friends, it looks like it's minus 8.5. I dare. Let's try that before we do my next little experiment moment here. Let me clear out what we got here from last one. Let's go up there. And by the way, yeah, some of you wonder, how do you clear those? Just hit clear. They don't, delete doesn't do very well, but clear will knock that whole thing out there for you. And let's put it in 5 halves. And we'll put an X right there. And we're going to subtract 8.5. We'll graph that. And that makes sense that we should have a half on there because we had a half in the slope, so it should work better. And let's put 5 in there, do a quick trace. I'm hoping that 5 is a happy place. And we get a 4. We get a 4. That's good news after all our little trouble we may have had going through there. So we know that's a good problem. Now, my point is, what I want us to do is, we could also have checked it with the 3 and the -1 on the trace. But I want to work it with 3 and -1 with you guys, all right? So let's go ahead, and we know the slope's 5 halves. That's not going to change. So let's go back to point slope moment. So there's y1 minus, that's y minus y1 equals m times x minus x1. And let's put some numbers in. New numbers, in this case, it's going to be y minus -1 equals to 5 halves times x. Oh, what are we going to do here, my friends? Everybody be good. Minus 3. And this, by the way, is going to go to +1, plus 1. All right, distribute. It's going to give us 5 halves x minus, so it looks like 7.5, because that's 15 over 2. So we got y plus 1. That mental math is great to have from time to time, isn't it? Now we subtract off. We got y equals, it looks like the same value. And it should be, what I wanted you to notice is that either point you use will get you to the same y equals mx plus b moment, all right? And again, this is called point slope, where we take y minus y1 equaling the slope times x minus x1. We found the slope by using rise over run, so that one had a little bit more work to do in it. But we know it worked right because, hey, we can verify it, and it worked on a calculator too, right? All of the above, looking good. Let's go to the next situation here. Let's talk about parallels a little bit. I mentioned that word earlier, and that throws people off a little bit sometimes. Well, it's not really that bad. This one may be very similar to the problem we just did earlier. In fact, it could be, hope it's not the exact same answer, but it says, let's write the equation of the line passing to y equals 2/3 x minus 2. We're going to pass it through the point 3, 4. Could be similar. We'll find out. I've been known to do silly things like this before. It gives us practice, right? Everybody says, yeah. Well, the slope I already have staring at me. There it is. It's 2/3. Now, what do I do with the slope? With the word parallel, that's kind of the little crimper here. What do we do with that slope, Ernie? Well, parallel lines, remember, have the same slope. So we're going to keep 2/3. We're not going to mess with it. And we're going to use that little point 3, 4. And I think this is going to be a fairly similar problem what we had just a minute ago. So let's do this point slope approach, that y minus y1. Everybody got that in their head? Everybody's got that in their head, right? We've done enough. You've been watching the show today. You're going like, whoo, wouldn't dream about that. That's a good thing. That's a good thing. So let's do it. Y minus 4. I believe we've done this problem already today, so we're going to move through this very quickly. I like that idea. And what do we do? What do we do? Is that what we got here? Maybe we haven't done this one before. Well, we'll find out. I think we have. Maybe we haven't. How many say yes? How many say no? We'll be fine. So let's do it. Let's distribute. Y minus 4 equals, how about it, 2/3 x, and we are going to have a minus 2 hanging on there, all right? So, almost identical problem. I think it was close. But let's move that 4 over, and that's going to leave us with 2/3 x. Oh, how about it? A little different. I'm glad to have something different there. And we've got a plus 2 going on there. Let's check it out on the graphing calculator. How about it? Y'all ready to go there? Let's see if that's going to work. We're going to check it through. We need to get rid of that little guy there. He's no longer helpful to us. And it's going to be y equals 2/3. By the way, when y'all put these 2/3, be sure you pop an x next to them because it does make a big difference. Sometimes we forget about little old x, and it is important. Now put a plus 2, and we'll graph. And again, use our lovely trace function and see what do we come up with. Well, that looks pretty, doesn't it? I look like, I think 3 4's on there. Let's find out. Trace it. The 3. Press enter. Gosh, 4's there. Always good to know that, isn't it? And there you go. There's your quick, simple approach to it. Again, those of you like to use the y equals mx plus b, just remember -2 was there a little bit earlier. Now, would it be parallel? Hey, why not? Let's go back to the graphing calculator and find out. Just occurred to me, we have to have our original one in there. It would be nice to look at our original one anyway. So let's go back to y equals and flip down there, and we can compare. Keep that one in there. This is what's the beauty of a graphing calculator. You can compare graphs. You can compare, and you compare all the good stuff there together. And let's see where we are. Put a subtract. Don't put the -2 on that. That'll give you a syntax problem. I keep mentioning that, but it happens a lot of times with students. They get excited, and they go that first thing, and they're, oh, beautifully parallel, and we know it works. All right, so let's clear those out. Let's get to our last problem here. Let me have, yeah, thank you guys. Let me have just a little bit of breathing room there. You guessed it. The other P word is coming out as perpendicular, all right? And you say, well, Ernie, it looks kind of, it's like, is that the same problem? It's the same slope, but what's going to happen here? What do we do when we have perpendicular lines? The slopes are not the same, absolutely. So right now, we're going to take a little look at this thing. That slope is 2/3. We aren't interested in that one. That's going with this. We want to use, you remember, opposite reciprocal slope. So reciprocal means 2/3 is going to become 3/2. And opposite means we're changing the signs. Now, this one was positive to begin with, so that's going to make this negative. If this had been a -2/3, we'd be looking, George, at 3/2. Positive. We change the signs. That's why I don't like to use the word negative reciprocals. You'll hear that sometimes. It's not really true. It's opposite reciprocals. You're changing the sign. You're also interchanging the numerator and the denominator. That's the reciprocal business. So there you go. So this, my friends, that's where we're going to go with this. And you know what? How about it? Point sloping. Let's do point sloping, all right? So that y minus y1 business doesn't change, does it? See, once you learn a formula and you use it 4 or 5 times, ingrains in your brain. It's all there. So let's put in our slope again, and that's, of course, what is it? X minus our x1. You've got it. Not the 2/3. No, don't use that. And don't worry about that 3. That 3 is just a nice little reference there. Just a little reference to throw you off, right? But just use what you got. How about it? Let's go with y minus, what are we going to do? What are we going to do? Y minus 3. Be sure you put those coordinates in correctly. How about it? -3/2 for the slope. We got that. We got our x and -4. Well, this time Ernie was nice. He didn't mess you up with a fraction, did he? Well, we got a fraction here, but it's going to take care of business. So let's go with it. Y minus 3, that equals, again, watch your signs on this, friends. Watch your signs. We got a -3/2 x. We're going to distribute. Remember I said that word, the big D. Don't mean Dallas. That's probably hit a copyright infringement right there, but who cares? Let's see. We're going to say 2 into -4 goes -2, and we add 6. Actually, we all care, don't we? We know that's a song, if you haven't heard that. And let's see. Let's do something with this thing. We're going to we're going to lose that, right? We're going to lose that 3. We're going to add it to the other side, which is going to give us a -3/2 x plus 9. And you know me, the magic moment is that going to work? Let's go back and check just real quick, all right? First of all, did we do the sign changes correct? It is a plus, and 3/2 of 4 is going to give us 6, so I think we're good. Got the -3. Let's check it out and see. So put our point back in here, put in a 4. Everybody good on that? We put in a 4 in there. That's going to give us -6 plus 9, which gives us 3. I know, we want to see it on the calculator. We want to see it on the calculator. Well, let's do it here. Let's clear, hold on, let me get those cleared. Clear those out. Let's put in our beginner equation, which was what? Probably the same thing I just deleted, right? 2/3 x plus 3. I like it when I can have fun with you guys. I hope you really realize that we can have fun with math. Oh, that's the second one, isn't it? Got a little carried away. Let's buck up here a little bit. We'll put the other guy that we just found. How about it? -3 halves x, and we had a plus 9. That's kind of crazy, isn't it? And we'll enter that. let's graph. I hope they look pretty perpendicular. There we go. There we go. By the way, remember you can zoom 5 to make sure that will work. I also would like to see if on the second one, I guess is what we were looking for, which would be, well, I think it was the blue one. Let's see. Let's put a trace on there, see where it goes first. Now, that's how we know, because you know what? It tells you what you're going to use. So let's put it right in there. Let's see what happens when we put in the 4. We enter. We got a 3. Yes! Life is good. Life is good. And hey, with just a half a minute to go. Did you get it right? Everybody get it right? And again, the graphing calculator is a great way to check your work on a problem like this. Again, remember those slopes. Opposite reciprocals, point slope formula, slope-intercept form, check it. Easy way to go. Hey, thanks for tuning in this afternoon and or evening or wherever you managed to get to us. And again, we will see you around next time.